And this question is given that a typical salt, a hard mud particle of radius 20 micrometer, is on the top of lake water. So the radius of this one is given as 20 micro. Micro means we can take it as 10 raised to 6 meter. Is on the top of lake water. The density is means the density of water is given as I think but 2000 kilogram per meter cube, and the viscosity of lake water is given as I think but one density is viscosity of lake water is this one, and its density, so density of object is given as I think by 2000, not the density of water, and density of the salty water is given as let's say around 1000. The lake is still, that means there is no internal fluid motion. The terminal speed with which the particle hit on the bottom is. So our aim is to find out what about the value of terminal velocity attained by this. So we can use the equation for terminal velocity. That is 2 divided by 9 into r square g into density of object minus density of liquid divided by the value of coefficient of viscosity. So if you are putting the value, you can try 2 divided by 9 into r square. We can take it as 400 into 10 raised to minus 6 square, which is 10 raised to minus 12, into the value of g, which is 10, and density of object it is given as 2000 minus density of liquid, that is 1000, divided by the value of coefficient of this viscosity, which is given as I think but 101 millipascal second. So we can take it as milli means 10 raised to minus 3. So we can just put the value of this one as 10 raised to minus 3 over here. Then we'll get the value for it, which is equal to, we can write 2 divided by 9 into, this is going to be 4 into 10 raised to minus 3. Or we can write this is equal to 8 divided by 9 into 10 raised to minus 3. Or this can be written as around 0.88 into 10 raised to minus 3, which we can take it as 0.88 millimeter per second.